The gamma bursts are located in very far away galaxies, meaning billions of light years.
Explosions in space, mostly of supernovas.
To the velocity of light, 50 times brighter than the brightest source in the sky. The total energy of a mass equivalent to one sun, converted completely into radiation.
Dr. Enrico Costa of Italy's National Institute of Astrophysics was involved from 1981 in Italy's plan to build a satellite to monitor transient X-ray sources in space. The Beppo-SAX was launched in 1996.
Originally, the gamma bursts were not a part of this program of Beppo-SAX.
The satellite was equipped with narrow-field instruments, wide-field cameras, and a force-switch detector system with scintillating crystals, which was converted into a gamma-ray burst monitor. Dr. Costa led a team to use these tools to detect and analyze gamma-ray bursts. On February 28, 1997, the monitor detected a burst.
After a gamma burst, there is a delayed emission that lasts a few days or a few months. And this is sufficient to go deeper and deeper with progressively different and better instruments.
Wide-field cameras localized it within a 3 arc-minute radius. Then the satellite was turned, and its narrow-field instruments quickly repointed at the source down to 1 arc-minute.
We decided if this source was associated with gamma rays, it was expected to fade.
It faded on March 3rd.
So this was the first clear detection of what we named an afterglow of the gamma burst.
The first time that we see the afterglow, everyone got crazy because we know that it was a very, very important result.
With Beppo-SAX, we arrived to understand where the gamma bursts are located, how distant they are, how much energy is really involved in this explosion.
The Beppo-SAX detected 1,082 GRBs in its 6 years in operation.
They can also help us to understand what there is from the emission site to the Earth.
Enrico Costa is a very, very good science. He is also a very, very clever man.
Beppo-SAX was the first satellite built and controlled by Italian astronomers.
Beppo-SAX demonstrates that in Italy we can also do big science in astronomy. When I entered in the university and decided to do physics, I was meaning to do something like this and not to do ordinary, say, science.
At the University of Rome, Enrico's thesis was on a rocket experiment in X-ray astronomy using a silicone detector.
I have a strange relationship with sky because from 14 to maybe 17 I was an amateur astronomer and I could know every star in the sky. Since I became an astronomer, I'm more involved in instruments with electronic readout.
Since Beppo-SAX, Costa's team has worked with another all-Italian satellite, the Agile, to detect very high-energy gamma-ray bursts, and significantly, one from the Crab Nebula. Looking to the future, Costa's group is developing new instruments to measure the polarization of X-rays, a completely unexplored area.
How are these preamplifiers doing?
I check it for prepare.
It was at a balloon flying experiment for Beppo-SAX instruments that Enrico met his wife Elda, a linear electronics expert.
He was the first pleasant physicist I've met.
I was attracted by her for many things, physically and also how she would walk. A way of walking. Not strictly sexy, it was very decided. I think I liked her immediately.
Yeah, immediately.
They were married in 1989. The family lives in Rome. Son Ettore majors in history and daughter Elettra in law.
They taught us interesting thing is being physically and emotionally close to us, despite of this war.
I am rich in memories. When I was small, he taught me how to swim. He was always available on Sundays. Even though he was busy, he would devote his time to us.
I'm just learning that I was considered a present parent, while myself felt a little bit guilty.
We always tried to organize and to find the time for the kids.
Enrico has lived in Rome for 55 years.
I'm a lover of living in big cities. This is one of the best.
He will retire next year after turning 67.
I think my life will not change. I cannot really imagine a life without doing experiments of thinking to new things.
Gamma-ray bursts were first seen in the 1960s by U.S. Air Force satellites spying on Russia and China.
Unbeknownst to myself, for several years, until 1973, they were seeing bursts of cosmic gamma rays coming from different directions, but these detectors were very small. They only saw about 10 or 20 of them a year.
Then in 1978,
NASA came out with what is called an announcement of opportunity to fly large experiments on a spacecraft that they called the Gamma Ray Observatory. It just so happened that I had a good team that I had put together here to submit a winning proposal.
and for the next 13 years at NASA's Marshall Space Flight Center in Huntsville, Alabama, Jerry Fishman and his team built BATSI, the Burst and Transient Source Experiment.
Several hundred people were working on BATSI during its design and development and testing. It was actually the first large experiment totally dedicated to studying the gamma ray burst mystery. This was a spare detector module. There were 9 of them built. Now with 8 detectors on the observatory, we're able to see the entire sky at the same time.
BATSI was attached with 3 other experiments to the Compton Gamma Ray Observatory and put into orbit by the space shuttle Atlantis in 1991. Before it went up,
the conventional wisdom was that these gamma ray bursts were caused by what are called neutron stars that are scattered throughout our galaxy.
But the BATSI detectors recorded gamma ray bursts in all parts of the sky, suggesting the origin was outside our galaxy.
Finding that the gamma ray bursts were uniformly distributed on the sky was a surprise to everybody, including us. It was a little hard to accept for most people at first, and for some people it was hard to accept even years later, until finally the Beppo-Sachs observations confirmed that gamma ray bursts really were coming from distant galaxies.
The realization that these were actually the largest explosions in the universe, and they were much, much farther away than we ever thought was possible, was a profound change in our mindset.
Over the next 9 years BATSI was in space, it found about 1 gamma ray burst per day, some 2,700 in all, of varying duration and intensity.
The BATSI experiment could only get the rough locations of a gamma ray burst to a few degrees. And to an optical astronomer, a few degrees is like looking at hundreds of thousands of stars. They really needed better locations to get an optical counterpart to a gamma ray burst. And that's something that BATSI couldn't do. It had to wait until Beppo-Sachs was in orbit.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon.
It was a very exciting time in the space program.
The first moonwalk was in 1969. The next year, Jerry graduated from Rice University in Houston with a PhD in space science. And he took his wife, Nancy, pregnant with their first child, to a new life.
I was pretty upset about having to move here. But in the years since, I've taught in the Alabama public schools, and both of our sets of parents have moved to this area. Our children have settled here, and it really is a pretty good place to live and to bring up kids.
We've got another place about 20 miles from here. It's a log cabin in a wooded area. I like to go up there and kick back. Sometimes I'll take other family members with me.
Yeah, it's because your mouth isn't that big.
Yep, nice view. Nice place you have here.
Aren't you glad I bought it for you?
Mm-hmm.
Jerry continues his work on gamma-ray bursts.
The Fermi Gamma Ray Space Telescope was launched on an unmanned rocket in 2008, and it's presently in orbit, sending back data continuously. And we're analyzing that data for gamma ray bursts.
He's a co-investigator on the project.
A great scientist. He's got a scientific intuition that I think most scientists, including myself, which we had. He just knows what to do.